right, so before we start, I want to go over a few things. Who remembers what we did yesterday? What did we learn about? Okay, yes, that was a review, but what did we learn? We learned about prime numbers and what was the other one?
Composite.
Composite, good job. What is a prime number?
It's a number.
Raise your hand.
Has only two
Has only two what?
numbers.
Two factors, so yes. And what is a composite number?
A composite number is a number that has a lot of numbers.
It has more than two factors. So a prime number has two factors, and a composite number has more than two factors, right? So
Yes.
what is a factor? Can you guys tell me what a factor is? Because we're using the word factor, but do you know what the word means?
Factors are two numbers that equal one big number.
Yes, it could be two numbers. It can be more than two numbers. So does anyone else want to give me another definition?
Numbers that multiply. When you multiply them, they equal.
Another number, yes. Or it can be a number that can be divided by another number evenly. Okay? All right. So now we're going to see today a word that says divisible. Does anyone think they know what divisible is? What word does divisible sound like in math? What word?
Divide.
It sounds like divide. Division. So what do you do when you divide? And what do you do in division? Raise hands. I see my same students answering, so let's see. Austin. No, I asked, what does it mean to divide? When you're dividing something, what are you doing?
It means to find out what is the multiplication but backwards.
Yes, division is multiplication backwards. So when we divide, we're breaking stuff into groups. We're breaking the amount of things or the number into groups. Okay? So today, what we will be doing is you guys are going to be able to use division and the associative property of multiplication to find factors. Do you guys remember what the associative property of multiplication is? That one may be a little tricky. You guys may not remember that. So I'll help you guys with that one. So I'm going to show you guys. So the associative property of multiplication is a property that just says it doesn't matter what order you multiply in, you will still get the same answer. So let's say we do, okay, we can do it up here. 2 right? We have 2 times 3 times 5 equals, equals 3. Right? So this top answer, I heard a couple of you guys calling out. Can I see a hand to answer what the answer is?
30.
This one's 30. What is this bottom one? Well, let's do it together. The top one's 30 and they equal each other. So let's do it together. We'll go to our parentheses first. 2 times 5 is what? 10. So 3 times 10 is what? 30. So these equal each other. And that is what the associative property of multiplication is. All right. So now that we know what all of those words mean, you shouldn't have a hard time with figuring out how to break these problems apart. All right. So our first problem says Luke counts a total of 75 cans. 30 of the cans are tomato soup. They are arranged together in an equal row to form an array. Draw a box around the cans to show one way the tomato soup cans could be arranged. All right, so we have the sentence here. What are some important things in the sentence? What should we be circling? What are the important details? So 75 soup cans is important because that's the total amount, so we know he has a total of 75. And if we see here, this is 75 cans right here. Each row has 5 in it. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. So these are the 75 soup cans. What else is important? 30. Why is 30 important? He has 30 cans of what?
Tomato soup.
Tomato soup. Okay, so now that we know the number 30 is important, what will we be doing with that number 30? Carla. Stephanie. Michelle. Well, it says he has a total of 75 soup cans. There are 30 cans of tomato soup. So we know he has 30 cans. It tells us they are arranged in equal rows. So now we have to take those 30 cans and arrange them in equal rows. So we have to think about, hold on 1 second. We have to think about a way we can arrange these 30 cans in equal rows. And there are multiple ways we can arrange these 30 cans. Yes.
You can arrange by subtracting.
Well, not by subtracting. So this is what we're gonna do. We have 30 cans, right? We have to think of 2 numbers that we can multiply that will equal 30. So turn and talk to a partner and talk about 2 numbers you guys can use that will equal 30. I'm gonna give you guys 30 more seconds. All right. So now that we know there are multiple ways it can be arranged, what is one way? Yes, one way can be 5 times 6, right? So we have 5 rows. We can 1, 2, 3, 4, 5, 6. So now we can just do 6 in each row And don't we see that each row is equal? All right, now this isn't the only right answer, so what's another one we can use? 3 times 10. 3 times 10. And if we use 3 times 10, then that will equal what? 30. So both of these will equal 30. Now, there is one more we can use.
30 divided by 5?
Well, not 30 divided by 5. We're using multiplication, so we can't use division.
30 times 1.
30 times 1. That is another one. It would just be one group of 30. What is one more?
15 times 2.
Yes, 15 times 2. So it would be how many groups of 15? 2. 2 groups of 15. Yes, so these are all the answers you could possibly have. And I want you guys to shade in your picture according to whatever answer you chose. So if you chose 3 times 10, you should have 3 groups of 10 shaded. If you chose 2 times 15, you should have 2 groups of 15 shaded. All right, does everyone have their picture shaded in?
Yes.
Who needs more time? Okay, I'll give you 1 more minute. Now, was anyone confused with this problem? No. Okay, does anyone have any questions? No. Okay. So now for number 2, we are given this equation. Can someone read the equation for me? Read the equation.
Okay, complete the equation. 42 divided by 3.
Yes, 42 divided by 3. So we will be taking the number 42 and breaking it apart into 3 equal groups, right?
Yes.
Okay. So now I'm also going to show you another way we can try to do this. So we are going to create a number bond. Does anyone know what a number bond is?
Yeah, we did that.
You guys did it before, right? So it looks familiar. So we're gonna take our number 42 and then we're gonna break it into 2 smaller numbers. So what are 2 smaller numbers we could break it into? I'm going to break it into 30 and 12. Now both of these numbers are divisible by 3. So 3 can go into both of these numbers, right? Because 3 times 10 equals 30 and 3 times 4 equals 12. So now we know that both of these are factors. And then we have 4 and 3, right? So we know that both of these numbers, 3 can go into it, right? So we broke up this number bond. And we decomposed 42 into 30 and 12. So that just shows us how we can break this apart to try to figure out the answers, okay? All right. Now we're gonna do our actual problem, right? 42 divided by 3. I want you guys to now work on 42 divided by 3. How can 42 be broken up into 3 equal groups? What number will we get? You can turn and try to talk to your partner to try to get the answer. Also, you can use your number bond to get the answer, but there's a way to think about it. So I broke the number bond down, right? If we take away each 3 from after breaking the number bond down, so we cross off this 3 and cross off this 3, what 2 numbers are left?
10 and 4.
We have our 10, we have our 4, right? Now, if we take our 10 and 4 and we add them together, what number is that?
I got it.
14. All right, so now you're gonna see how this works. 14, 14, and 14. Let's add them back together and tell me what number you got. What's 4 plus 4?
8.
Plus another 4?
12.
We put our 2 down. We bring up our 1. What's 1 plus 1?
2.
Plus another 1?
3.
Plus the last one?
4.
42. So 42 divided by 3 is what? 3 groups of what?
14.
14. Does anyone have any questions?
No.
Do you understand when breaking this number bond up and then breaking down these 2 numbers and then crossing off the 3, how we got the number 14? Okay. What about my friends over there? Do you guys have any questions? Okay. So now turn to your next page. And for this part, we are going to be trying to figure out is one number the factor of another number, and then we have to explain why or why not. All right, can somebody read this for me?
Answer each question. Show or explain your theory. Is 3 a factor of 47?
Is 3 a factor of 47? Let's think about it. Now, if we break 3 up, so we can use our number bond again, okay? So we can use 47 and then break up 47, right? So now we can break it up to 30 and 17. Can 3 go into 30 equally? Can 3 times another number equal 30?
Yeah.
I see you guys nodding your head. So what number is it?
47.
Well, we're talking about 30. So can 3 go into 30 evenly?
Yes, and the other number is 10.
10. So it would be 3 times 10. All right. Now can 3 go into 17 evenly? No. So, because 3 cannot go into both numbers equally, would 3 be a factor of 47?
No.
No. So no. 3 is not a factor Why is it not a factor of 47? Because it can't, Madison? Because it can't go into the number equally. Good job. All right, now for the next one, can someone read it for me?
Is 5 a factor of 85?
So is 5 a factor of 85? If we skip count by 5, can we get to 85?
Yes.
Yes. So our answer is yes. 5 is a factor of 85. And a lot of you guys knew that one immediately. You know what's the trick? If there's always a 5 or a 0 at the end, then it goes in equally, as long as it's the number 5. Now for the next one, it says, is 7 a factor of 84?
No.
So, I want you guys to think about, can 2 numbers multiply and equal 7? I mean, equal 84. Can 7 and another number multiply and equal 84?
Yes.
Oh, yes, I hear some yeses. Yes?
Yes.
Do all of you guys know why? Does anyone not know why? You don't know why? Okay, so turn and talk to a partner.
7 has 10 because 7 has 10
When we come back, you will be the first to know, okay?
Actually, I think it's 11. No, I think it's
12.
All right, let's come back. So I heard you guys talking and I heard you guys trying to figure out what 2 numbers equal 84 when multiplied. 7 is 1. What is the other one?
12.
12. Yes, it's 12. So the answer is yes. 7 is a factor of 84. 7 times 12 equals 44.
Yes.
Who needs a little more time to write? Okay. All right. So for our next one, can someone read it to me? Who's gonna read the next one for me? You can read it.
Is number 6 is 4 a factor of 55?
Oh, you guys all knew that immediately. Why is it not? So we have no. 4 is not a factor of 55. How do we know 4 is not a factor of 55? What were we just talking about? Well, this is the number 4. 4 cannot go into 55
But if it was 5, then it would have been.
evenly. Yes, and if it was 5, it would have been able to go in evenly. All right, number 7 is 6 a factor of 73? Here, let's try to use number bonds and break it down and try to get the answer. 73, right? We can break it down into 60 and 13. So can 6 go into 60 evenly?
Yes.
Yeah, so 6 times 10 will equal 60. Can 6 go into 13 evenly? No. If it was 72, then yeah. But because it's 73, no. So the answer is no. 6 is not a factor of 73. All right, do you guys all have this copy?
Yes. Yes.
Okay. So you remember earlier we were talking about the associative property of multiplication? All right, now here is where we are going to use it. All right. It says use the associative property of multiplication to find the factors of 72. So when we're dealing with factors, factors are just pretty much all the different numbers that can multiply together and equal 72 evenly, okay? So we have to think of all the combinations that we can multiply and that will equal 72, okay? All right. So I want you guys to turn with your partner and come up with two numbers that could be groups of three, 2, 3, or 4, and come up with two multiplication solutions that equal 72.
One
All right, 15 more seconds.
Yes.
All righty, let's come back.
14.
Okay, that's 1. 2 times 36. What's another? 9 times 8. Yes, that's another one. That's a good one. Does anyone have another one? So you guys have to remember these because these are all the factors we're going to need at the bottom.
Me?
Yes.
9 times 8.
Yes, good job. So now let's use 9 times 8. Okay. So now we have 8 times 9 equals 72. So now we come down here and we can break apart 8 times 9. Now what two numbers can multiply and equal 8? 4 times, I'm talking about equaling 8. What two numbers can we break down to equal 8? 2 times 4. So we have 2. Hold on. We have 2 times 4. Okay. Now, what two numbers can we break down to equal 9? What times what equals 9? 1 times 9. What's another one? 3 times 3. So 3 times 3. Okay. So now, this is where the associative property of multiplication comes in. So it doesn't matter how we do it. We know that we have 2 times 4 times 3 times 3, right? Yeah. So now we can take it and do 2 times 3 times 4 times 3. These are all the same numbers. So no matter how we multiply these numbers, we're still going to get the same answer. Because right here, this equals 8 and this equals 9, right? So right here, this equals 6 and this equals 12. See how it brought us back to 6 times 12? So it doesn't matter which way we flip around these numbers, we will always get the same answer. Okay? All right, so I want you guys to copy this in your book. Don't copy it on the line, just copy this in your book. Because on the line, we have to put all the multiples of 72. So you see all those numbers you guys were telling me can be multiplied and equal 72. That's what we're going to put on this line. Alright, now I am going to erase this, so now we can write down all the multiples of 72. So we're gonna list the multiples in order. So we have 1 times what equals 72? 72. So we know 1 is a multiple and 72 is a multiple. Now, 2 times what number equals 72?
2 times 36.
So we have 2. We have 36. All right. Now, what other numbers can we use?
4 times 23. 4 and 23.
Okay. Now, we also use what number right here?
We can use 3 times 24.
Good job. And then what other number? We have some up here.
6.
Now, give me 2 more numbers.
9 and 8.
8, 9. So we have 1, 2, 3, 4, 6, 8, 9, 23, 36, 72.
We don't have 12 in there. We have 12 in there?
Oh, good observation. So here, 12. Let me see. We'll add 12 in right there, and you guys can add it in at the end. 12.
Can you tell the numbers again?
We have 1, 2, 3, 4, 6, 8, 9, 12, 23, 36, 72. There's one number that was a mistake on there, and it was actually 23.
Oh.
So it's just 1, 2, 3, 4, 6, 8, 9, 12, 36, and 72. You guys all have a copy?
Yeah. Okay. Wait. What number is
Which one? 12, 36, 72, which one?
all the work that comes before the 72?
36. that copied. Now let's turn to the next page. Now it says complete each equation. Use the pictures to help you then answer the questions. So we're gonna do the first one together, then I want you guys to work on the rug with one other person to complete the rest of the page. Okay? All right. So number one, we have pictures right here of pencils, right? So how many pencils are here? How many? All say it together. 7. So we have 7 equals 1 times what number? 7. So now, is 1 a factor of 7?
Yes.
Yes. Is 2 a factor of 7?
No.
No. Why is it no? Why is the answer no?
Because 7 is not an even number.
Yes. Good job. So for number 2, we have basketballs right here. How many basketballs do we have? 10. We have how many groups of 10?
2.
2 groups. How many groups of 5 to equal 10? 2 groups of 5. So 10 equals 1 times what? 10 equals 2 times?
5.
Is 3 a factor of 10?
No.
No, because it can't go in evenly. Is 10 a factor of 10?
Yes.
All right. Now, for the bottom part, it says complete each equation, then answer each question. So they give us it's 18, we have to figure out 1 times what equals 18, 2 times what equals 18, 3 times what equals 18. So answer those, then you have to answer, are these numbers factors of 18, okay? So I want you guys to do 2 and 3, and I am going to give you guys 3 minutes. You guys should be able to do it in 3 minutes.
Yeah.
Yes, you can work with a partner quietly. Yes, 3 and 4. Okay. Okay. Is there a place where you can sharpen your pencil? Sharpen it.
Yes, no. Yes, no.
All right. So 1 times what equals 18?
18.
And you guys should be able to pull all of these answers out together, and everyone should know these answers. 2 times what equals?
9.
3 times what equals?
6.
Good job. Is 6 a factor of 18?
Yes.
Is 8 a factor of 18?
No.
Good job. Now,
24.
2 times 4. Good job. 3.
Eight.
I thought you were on the last one.
Discuss it with each other because I hear 2 answers. Which one is it?
Eight.
It's 8.
Oh. And then 6.
Good job. Is 10 a factor of 2? Is, all right. Do you guys have any questions? All right. So now, for these, it says answer each question. Show where explain your thinking. Is 2 a factor of 25? No.
Yes.
No, why not? Why is 2 not a factor of 25? Can I see some hands?
No, it's no.
Because when you count by 2, you won't get to 25.
Okay.
Miss Joseph,
Yes.
you're in college?
Yes.
How old are you?
We'll ask those questions later. Now, you guys don't all have to write this explanation, but you guys all have to write your own explanation. Is 3 a factor of 54? Can 3 times another number equal 54? And you can't look at the 3 times tables up there because it doesn't go that high. So let's skip count by 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 40. Oh, you guys are stuck. 42, 45, 48, 50, 50 what? 51 and 50, 54. So is 3 a factor of 54?
Yes.
So yes. Is 4 a factor of 65? No. Is 6 a factor of 78?
Yes.
No.
Yes. Yes.
Okay, why is it yes?
Because 6 times 2 is 72. And
Well,
if you add another 6 is 78.
Yeah, so 6 times 13 is 78. All right. All right. So now we're going to use some associative properties.